Hey everyone, welcome back. So in the last video we solved a problem which was majority element 1. So today we are going to solve another version of that problem which is majority element 2. It is also using same concept of Boyer-More voting algorithm. So to understand this problem you should know the problem majority element. Okay, so let me first explain problem majority element, then we will move to the majority element 2. We had a array like this and we have to return a element which is having count more than n by 2. Means in this problem we have to return a element which is having count greater than n by 2 and n is our size of the array. So 1, 2, 3, 4, 5, 6, 7. 7 by 2 is approximately 3. So 4 is greater than 3. So we can say 2 is our majority element. Okay. So in that problem we were using a concept of Boyer-More voting algorithm. In that we were taking num 0, count 0. As we are move forwarding, we are voting the element and updating our num. So initially num is 1 and count is 1. Then we will move to the next element. So this time num still be 1 and count becomes 0. At the next element our num will update because our count already becomes 0. So we cannot go into the negative. So now our count will become again 1 because it is associated with the new number. Now again we will move forward and num will 3 and count becomes 0. Again our count becomes 0. So we will update our num and count will again become 1. Then we will move forward, then our num 4 and count will become 0, right? Then again this time our num will update again and count will become 1. So the element which remains is the majority element. So that was the concept we were using in majority element 1. So before moving to the majority element 2, we have to understand one concept here, that we have array, right? And it is asking you to find count greater than n by 2. Why it does not ask us to find multiple answers? Means 2 is one of the answer. Can it be another number be my answer? So let's say I have array like this and the size is 7, right? If I ask you to find two element whose count is greater than n by 2, so can you able to do it in this example or any other example? You cannot do it, right? Because if you sort this array, it will become something like this, okay? And the array size is 7. If you divided it will become 3. So it means you are making a partition into the array. So if your partition lies somewhere here, right? So is it possible for two elements whose count will be greater than n by 2? No, right? Because in this case our 2 is greater. So 3 element is separated this side and 3 element is separated this side. So only one extra element can decide which one is your majority element. You cannot put extra one, right? If you put extra one, your array size will become 8 and then it will become 4. So your array will become like this. So in this case you cannot find any majority element because we are talking about greater than n by 2. We are not talking about greater than equals to n by 2. So we are talking about strictly greater than n by 2. So you can have only one element which is having frequency greater than n by 2. Okay, so similarly we have majority element 2. Okay, in this question they asked us to find all element that appear more than n by 3 times. So this time it is asking to find all the element which appears more than n by 3 times, right? So if we take this example and our array size is 7, so if you do a division by 3, it will be around 2. So you need to find elements whose frequency is greater than 2. So this time we have 1, 2, 3 and 1, 2, 3, 4. So this time we have two elements which is having frequency greater than n by 3, right? So you have to return both of them. Okay, so you can also do it using map similar to the problem which we have done in majority element. Okay, so now we have to solve it in a big of n and big of 1. So in this concept we seen that if you want a number with the frequency greater than n by 2, there is only one element is possible in that array. Similarly, this time you are dividing your array in 3 portions. Means if you sort this array, it will again becomes like this, right? So if you divide your array, basically you are dividing something like this, means in 3 portions, right? So that means only 2 answer is possible, right? Because for this case we have number of elements greater than 2. For this case also we have number greater than 2, so we can take both of the elements, right? Let's take different example. So we have something like, okay, array size is 8. Okay, let's take one more element. So array size is 9, and if we divide it by 3, it will become 3. So you should have elements which is greater than 3, right? But 1 2 3, 3 greater than 3, no. 1 2 3, 3 greater than 3, no. 1 2 3, 3 greater than 3, no, right? So only 2 elements you can have which is having frequency greater than n by 3, right? That's why in majority element 1 we know that if we divide our array, only one answer is possible. That's why we were taking num and count, right? There wasn't any possibility of multiple solution. But in this case there are possibility of multiple solution, but the possibility is only of 2 elements, because if you are dividing your array in 3 portions, so 2 portions will be filled with the same numbers and another portion should have extra numbers, so the other portion can have frequency greater than n by 3. So there is only 2 possible answer for this question. So we can again use our Boyer-More voting algorithm, right? If there was multiple answer, like you can have 1 also, 2 also, 3 also, 4 also, 5 also in a single array, then you cannot use your Boyer-More voting algorithm. So it is still possible to use this algorithm in this question, right? So let's take an example. So we have something like this. Okay, now in this case we will be declaring count1, num1, count2, num2, right? Because we know only 2 answer will be possible, so we can easily declare 2 variables or 2 pairs of variables, right? So initially we are at this index, so we can update our one of the num and the count. So let's update this, and this will remain 0. Now let's move to the next number, right? So in this case our count and num is already updated, so they will remain same, and your count2 and num2 will be updated. So 1 and 1. Now let's move to the next number, and now we will check these are numbers equal, no. Then we will check with this num2, these are equal, yes. So our count1 and num1 will remain same, and our count2 num2 will update. So our count2 will become 2 and num2 will still be 1, because it is a same number. Now let's move to the next. Now again we will compare, is it same, no. Is it same, no. So both elements are different. If both of them are different, we will decrease count from both the element. Okay, now let's move to the next number. Now our count here becomes 0. If it is 0, then we will update this number, so it will become 1 and the number will become 3, and our count 2 will remain same. Then move to the next. The number is different, so our count will become 0 and num will remain same, and the count will become 2 here and num will remain same. Now if you look at it, our num1 and num2 both are majority element, right? 1 1 1 and 3 3. Okay, so in this case you have to handle multiple conditions, right? So if one of the count is 0, you will be update the count and the num of that pair, right? And if the number is different, you will reduce the count from both of them, else you will compare your current num with the previous, so you can update your count here. So the logic is similar to the majority element 1, but you have to handle count 1 and num 1, count 2 and num 2. So let's write a code, so you will be able to understand it. So we will be declaring num 1, count 1, num 2 and count 2. Then we will run our loop. Then we check our count 1 equals to 0. That means we will update our num 1 with the nums of I, and count 1 will become 1, right? Because it is the first time. Else if our count 2 is 0, we will update our num 2 and our count 2 will become 1, right? So these both conditions are for that time when your count is 0. Now we will have to check if our num1 is equals to nums of I, then we will increase our count 1. Similarly, if our num2 is equal, we will increase the count 2. Else, if both the number are different, we will decrease count from both the number, right? So this is our overall code. First you have to write a condition for if your count is 0, update your num and count num1 and num2 are same with the current value, you will update their count, and if the number is different, you will decrease your count. And after that you have to write extra code for checking that both majority element are really the majority elements. So let's write a code. So we have multiple answer, so we will declare a vector to store the answer, and I will reassign my count 1 and count 2 to 0, and I will run a loop to check if that number is really a majority element or not. So I will increase my, if num1 is equal to the nums of I will increase the count of 1. If num2 is equal to the nums of I will increase the count of 2, and after that I will check my count 1 is greater than n by 3, then I can push back the num1 into the answer vector if count 2 greater than n by 3 and num1 not equals to num2. Okay, so here I have written two conditions. First, we are checking if my count 2 is greater than n by 3, and we are also checking that same numbers are not the one we have in both the majority elements, right? It can happen that num1 also contains 2 and num2 also contains 2. So both of them will be having duplicate values. So to eliminate that, we are writing one more condition. Then we can push back into the answer. This is our whole code. So let's run it. So let's first declare our array size. After that, let's declare num1 equals to 0, num2 equals to 0, count 1 equals to 0, count 2 equals to 0. Then we will run our loop, and first we will compare count 1 equals to 0. That means we will update our new number. So num1 equals to nums of I and our count 1 equals to 1. Else if our count 2 is 0, we will update our num2 count 2 equals to 1, right? Else if our num1 equals to nums of I, means our previous num1 is equals to the current num, we can say count 1 plus plus. Else if num2 equals to nums of I, then count 2 plus plus. Else count 1 minus minus, count 2 minus minus, right? After this we will declare a vector, and we will reset our count 1 to 0, count 2 to 0. We will run another loop and we'll check num1 equals to nums of I, then we can increase the count of 1. Similarly for the num2, and after counting both the number, we will check count 1 greater than n by 3, then we can push it into the answer if count 2 greater than n by 3 and num1 not equals to num2, means both the majority elements are not same, then we can push our num2 into the answer. Okay, after this we can return our answer. So let's run it. Here should be count, there should not be any space. So our initial test cases got passed, so one of the test cases got failed for this. Okay, so let's try to dry run it by it is failing. So 2 1 1 3 1 4 5 6, so we have num1 count 1, num2 count 2, right? So initially all of them are 0. So at this both the count is 0, so we can update one of the num. So I will update num1 and count will become 1 and this will remain 0. At this element we already have count 1 and num1, so it will remain same, and our count 2 and num2 will be updated, so it will become 1 and 1. Then at this element we will compare this or this same, no, this and this is same, yes. So our count will increase here and num will remain same, and the num1 and count1 will remain same. Now at this position the element is different for both of them, so our count will decrease from both of them. Then here now we have here different case. You can see that our one of the count is 0 and num2 is matching with the num2. So simultaneously two cases happening. One of is that count1 is 0 and our num2 is similar with the new number, right? So our count1 is 0 and our num2 is equal with the nums of y. So both the cases are same, means both the cases are happening simultaneously. So in this case which one is getting the priority? So according the code we have written, we are giving the priority to the 0 condition. Means if our count1 is 0 or count2 is 0, then they will be first updated, then these else if condition will be skipped, right? Because in if else only one condition runs at one time, but in this case both the condition happening simultaneously. So if we follow along with our code, it will fail, because according to this algorithm the first condition should be nums2 equals to nums of y. Means we have to give the priority to this first, then after this. So let's make changes in our code. So here we will pick both of the count1 and count2 and insert here. We change the order of execution. So first we will check if the elements are same. If the elements are same, we will increase the count, and after that we have written the condition for the count1 0 and count2 0. So let's run it again. Okay, so here you can see our code got accepted. So you have to remember this, you have to give the priority to increment your count. Okay, so the order of conditions will change. So the time complexity will be big of n, because we are using only one loop and we are not using extra space, so space complexity will be big of 1. Here we are using vector for storing the answer, so at most it will be storing only two answers, 1 or 2. It cannot store more than 2 answers. So if you even taking that space complexity for this, it will be constant, right? Big of 2. And also it is a answer space complexity, so it will not be considered in the extra space. So our time complexity big of n, space complexity big of 1. So before watching this video, first watch the majority element one if you are not able to understand this question. So that's it for today. Until then, thank you everyone, have a nice day.